Hey guys, here is the first problem on our, okay, so this was our first problem. You guys got that one for your bell work. Here is problem number 2. Now we're going to do the quiz trade again. So I want you to write your answer on the board, and then I'll spin the spinner and we'll see who's got it. So here's problem number 2. I'm going to just do a reviewing. Okay, see if you can write the equation for this. Talk about it in your groups. Help each other out. Okay, so since this one shifted, first of all, it's an absolute value function. Shifted to the left 2, is that right? So we went x plus 2 inside the parentheses. That's a shift left of 2. And then it went down 3, so minus 3. Good. Looks like every table had it. Good job. Okay, next one. This one right here. Okay, there's a bigger graph of it right there. Okay, it looks like you guys got it right. It was 1 over x, what is it? 1 over x plus 5, and then the plus 3. Hey, just a second, I gotta. Yeah, it's 1 over x. It shifted to the left 5, and then it shifted up 3. So it was 1. What was it? 1 over. You got f of x equals 1 over x plus 5 plus the 3, because it moved up. This is a different problem right here, so don't get this one mixed up. Did everybody get it? I can't, because I erased it already. Okay. Oh, by the way, yeah, and it was a rational function. That's why it was like that. Okay. This is a new problem right here. This is your next one. Yeah, what's the... Well, let me turn this off and then I'll show you. Looks like y'all got the same thing. You got y equals negative absolute value of x. Was it minus 6? Plus 5. By the way, on the test, I'm not going to count it against you if you're within 1 unit from 6 or with 1 unit of 5, whatever the answer is, okay? If you're off more than that, that's because you're not paying attention closely. But I can see how you can be off 1. So I'll allow you to be off 1, but not more than that, okay? So what did the negative do, you guys? Flipped it over, right? Okay? The x minus 6 shifted to the right, 6 units. The plus 5 shifted it up 5 units. Good job. Looks like you guys are getting this. So you're going to write an example of a continuous equation. You want to write an equation, not a graph. You guys, most of you are pretty simple on that one. I'm not going to ask the question that way on that. I'm going to actually give you an equation, and I'm going to say, is this one a continuous function? Okay? So, but most of you guys wrote an equation of a line, which is continuous, because continuous just means that you can trace it without lifting your pencil. So if you have to lift your pencil, then it's not continuous, okay? All right. Now I want you guys to write an example of a non-continuous function. I didn't spell that right. Write an example of a non-continuous function. Okay, so rational functions, most rational functions work. Step functions like greatest integer function and trigonometric functions work. Square root is continuous. You start at the end point and you can go on forever without lifting your pencil. Okay? All right. Next question. I want to know is this one continuous or not continuous? I want to know if that's continuous or not continuous. But the answer is that it is continuous. Look, this is just a polynomial equation. There's no x in the denominator. So this is not a rational function. There has to be an x in the denominator for it to be a rational function. So any polynomial function goes on forever in either direction. There's no asymptotes to break it up or anything, okay? All right, good. Okay, next one. Okay, I want you guys to find the maxes and mins of that function. Okay, round these to 3 decimal places. Okay, so you all put in your calculator. You went to the trace function. You went to above trace. It says calc. That's the calc menu. You go to second and you hit calc, and you find the left bound, the right bound, and the guess, and you'll have your minimum and your maximum. Okay, what did you guys? Well, let's spin. Person number 4. Show me what you have. Okay, if you got 3.528 and comma 15.128 and 0.472 comma 0.872, I think you got it right. Is that what you guys got? I need your, now keep those numbers. Do not erase them. We're going to use them again. But tell me what they are again. What's my max? 3.528, 15.128. Okay, what's my min? 0.472, 0.872. Okay. All right, we got the max and the min. You need to know how to do that. That's an easy one because you can do it on the calculator. Find the max and the min. Now, here's the next thing. I need you to find where is this function increasing and where is this function decreasing. Now, keep in mind, do you name the x or the y intervals, you guys? No? The x intervals, right? You name the x intervals. So name the x intervals over which this is increasing or decreasing. Okay, so, Vipno, you got it right. Okay, let me see yours in just a second. Okay, you have, there's another place where it's decreasing, but you got those two right. Okay, where'd you get the 2.1, the 0.213 from? Well, look, a min is where you change. So that's why we got the min and max first. It's those numbers right there. Okay? Did you get, what do you have? That is correct. Okay? That is, that should be a negative infinity in front of that right one. Okay? That one is correct. Yep. Okay. Hey, for the most part, you guys got it right. Let me just show you really quickly. You guys, this function looks like this. If we drew the graph of it, isn't it coming down like this? Goes back up, and then goes back down, right? Okay, so as this function, you guys, I want all eyes right here for a second. As this function, as we're moving from left to right, we're going downhill, aren't we? We're going downhill. So it's decreasing, right? We're decreasing from, we're coming from the left forever. We're coming from negative infinity. From negative infinity till we get to this minimum point right here, the x value of the minimum point. What's the x value of that minimum point? 0.472. It's that number right there, 0.472. It's decreasing. And then, from there, you start going up until you get to the maximum point. So where is it increasing from? From where to where? To 3.528, right? It's going up. And then what does it start doing? It goes down. So it's decreasing from 3.528 to what? Positive infinity. As you move left to right, it's decreasing, then increasing, then decreasing. And we name the x intervals on which we go. Now, here, let me tell you guys what the biggest error is whenever I give tests on this. The biggest error is people use the y values instead of the x values to name the intervals. You can't name the y values because we're describing what the y value does as we're talking about increasing or decreasing. What we want to know is what left to right, when does that happen? So we want to know the x numbers where it's increasing and the x numbers where it's decreasing. Okay? All right, now, the last question on this one is what is the end behavior? What is the end behavior of this function? Now, you should be able to tell by looking at the equation of the function, this right here, as well as the graph. You should be able to tell the end behavior by either one of those two things. So on the test, if you don't know how to do it one way, you should know how to do it the other way. But I want you to use the correct notation, the correct symbols that we learned last time. Okay? So let's see how you do with that. Look it up in your notes if you need to. Yeah, you guys, I think you guys understand what, in English, I think you guys understand. What is this doing? Well, yeah, it goes up for infinity and down for infinity, but which direction? Left or right? As you go left, it goes up to infinity, and as you go right, it goes down to infinity, right? So that's what we're saying. But we got to put that in mathematical language. So we're going to write it like this. As x approaches, remember using those arrows? Infinity, what does f of x or y do? F of x approaches what? You guys, this means as x goes to the right. When we say x approaches infinity, y approaches negative infinity. It's going down, right? And as x approaches negative infinity, that means as x goes left, f of x does what? Yeah, f of x goes not right, it goes up. Yeah. No. You guys, you always use the highest degree term. Look, we can get this one by two ways. We can look at the highest degree term. Okay, all eyes right here for a second. Guys, eyes right here. If the highest degree term is 3 right here, which it is, then this is third degree polynomial, so any odd degree is either going to go up one way and down the other way, okay? Now, does it go up to the right and down the left, or up to the left and down the right? Well, if the coefficient is negative, then it's going to have a decreasing. Over most of it, it's going to be decreasing, so it's going to go down as you move left to right for the most part. And you can see that it does. This thing's coming from negative infinity. It goes up for a little bit, but then it's going to go down forever. Okay, it has a negative slope. So it's going to, as we go to the left, y goes up. And as we go to the right, y goes down. And so we set it like this. As x approaches infinity, that means as x goes to the right, f of x, which is the y is going down to negative infinity. And as x approaches negative infinity, that means as x goes to the left, f approaches in positive infinity. That means f of x goes up. Okay? Or the y value goes up. So that's the end behavior. Yes, Jack? No, it won't. You got to look at it. Sometimes functions go like this. Their end behavior is like that. Goes up to the left and up to the right. So as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. If it goes like this, it's not going to double back over because you can look at the degree and you can tell. You can look at the equation. You know, sometimes if you look at the graph, you're not sure if it keeps waving out where you can't see it, going up and down, and then going off in some direction you can't see. If you look at the function every time like this, you find the highest degree term, you know. If it's odd, it's going to go up one way and down the other way. If it's negative, it's going to go up to the left and down to the right. If it's positive, it's going to go up to the right and down to the left. You should have all this written in your notes. Okay? Then it's easy to transfer it on there. Okay, now, you're going to need to know end behavior for your test. Okay, let's do one more problem on end behavior. What if you have this one? What's that one going to do end behavior-wise? All right, looks like most of you guys got it. Look, since this is of even degree, they either both got to go up or they both got to go down, right? Okay, since it's a negative number, then they're both going to go down. Okay? So it's going to be this one right here. So we would write it like this. As x goes to the right, positive infinity, y, or f of x, you can write y or f of x, y is going down, which is negative infinity, right? And as x approaches negative infinity, that means as it goes left, y is also going to go down again. Okay? It's going down both ways. All right, do we have that? Okay, next problem. You guys? Find the inverse. Okay, looks like 3 out of 5 tables had it right. A couple of you guys had it wrong. Step 1 was to replace f of x with y. Step 2 is to do the inverse. How do you find an inverse? Switch x and y. So x equals negative 3, y minus 8. You add 8 to both sides, because now the next step is to solve for y. Divide by negative 3. So y equals x plus 8 divided by negative 3. And then you could write it as negative 1/3 x minus 8/3 if you want. But I'd rather leave it like this. Last step is to use the inverse notation. Write it in inverse notation. That's what you need to do on that. Okay, any questions there? So all you do is really switch x and y and solve for y. That's how you find an inverse. That's what an inverse is, switching the domain and range, switching the x and y. Okay, on this problem right here, I would like you guys to draw the inverse. Okay? Now, I want you to make a set of axes like this. I want you to draw this thing on there, and then I want you to draw the inverse as well. Hey, look, you guys. You want to see how easy it is? This is negative 2 comma negative 5. This is 1, 2, 3, 4, 5 comma 1, 2, 3. So 5 comma negative 3. This is 6, 7 comma 1, 2, 3. 7 comma 3. This is how you find an inverse. You switch the coordinates. Isn't that what an inverse is, you guys? Think about it. Instead of going to negative 2, negative 5, you switch them. You go to negative 5, 1, 2, 3, 4, 5, negative 2. Okay? Negative 5, negative 2. Instead of going 5, negative 3, you go to negative 3, 1, 2, 3, positive 5, 1, 2, 3, 4, 5. So negative 3 comma 5. And instead of going to 7 comma 3, you go to 3 comma 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And so that is the inverse. Don't forget that the inverse is a reflection over the line y equals x. It's symmetrical over that line. Do we understand that? Think you can do one like that on the test? because it's on there. Okay, here we go. I'm going to do another one like that. Oh, I'm good at chess. Okay, you guys find that one. Okay, all you do is switch the coordinates. Instead of -4, -1, you go to -1, -1, 2, 3, 4, right there. Instead of -2, 3, you go to 3, 3, -2. 1, 2, 3, 1, 2. Not, you don't switch signs, you just switch coordinates. 3, then -2. Instead of 1 and 2, we go to 2 and 1. Instead of 1 and 8, we go to 8 and 1. Looks like that. It's symmetrical over this line right here. Got it? Okay, next one. You guys, find all the asymptotes of that right there. All the asymptotes. Okay, you guys, to find a vertical asymptote. To find a vertical asymptote, you set the denominator equal to 0. Because you want to know what you can put in for x, times it by 2, add 5, and get 0. So I minus 5, and I divide by 2. That's the same as negative 2.5. So there's going to be a vertical asymptote at negative 2.5. You write it as x equals negative 2.5. Got it? To check for horizontal or slant asymptotes, the other name for slant asymptote is an oblique asymptote. But to check for horizontal and oblique, it only has one or the other or neither. You check the degree of the numerator and the denominator. If the degree of the numerator in this case is 0, right, on the top, and 1 on the bottom, the degree of the numerator is less than the degree of the denominator, it always has a horizontal at y equals 0. Remember that. That paper tells you all that. I would study that. Okay, next problem. Hey, you guys, hold on. I'm going to change this one. Okay, find the asymptotes of this one. What are they? Does anybody have them? That's 2 of them. You got one more. X equals 2 and y equals 3. Okay, this is how you do them, right here. Hey, you guys, if you set the denominator equal to 0, you add 8, divide by 2, then take the square root of both sides. You get plus or minus 2. Okay? When you take the square root of both sides, you get plus and minus 2. So there's your 2 vertical asymptotes, positive 2 and negative 2. Guys, when the degree of the top is the same as the degree of the bottom, in this case they're both x squared, there's a horizontal at 6 divided by 2 at whatever the coefficients are. You divide them. 6 divided by 2 is 3. So there's a horizontal at y equals 3. And 2 vertical right there. Okay, hey, you guys, listen. Okay, the test will be Friday. Okay, the test will be Friday. For sure, when you walk in the door. I would, this was me. I would, if it was me, I would prepare a good 3x5 card. I would study all these different types of problems we went over. Make sure you know how to do them. Okay? I'm going to do 2 examples when you guys come in next time find maxims, mins, and increasing, decreasing. But that's about it. I'd practice all the problems. I would study for it just like you study for any other test. Test Friday.